AWACS versus F-35. Can a giant radar actually see a stealth jet? What if I told you that a massive AWACS aircraft, based on a 50-year-old Boeing 707, can actually detect one of the most advanced stealth fighters ever built? And what if I told you that even when it does, it still can't reliably engage it? That's the real story. Not stealth is dead, not AWACS is useless, but a high-stakes contest defined by physics, geometry, and time. Let's start with the F-35. The F-35 Lightning II was never designed to be invisible. Invisibility is a myth. Stealth is control. Control over when you are seen, from where you are seen, and how clearly you are seen. At its core, stealth is about reducing detection range and degrading tracking quality. The F-35 achieves this through two primary mechanisms. First, shape. Every edge is aligned. Every surface is angled with intent. Incoming radar waves are redirected away from the source rather than reflected back toward it. Second, materials. Radar-absorbent coatings convert part of the incoming energy into heat, reducing the strength of the return signal. The result is a drastically reduced radar cross-section. But here is the critical point. Radar cross-section is not a fixed value. It is not a constant. It changes with aspect angle, radar frequency, and the surrounding environment. And this is exactly where most people get it wrong. Now consider AWACS. AWACS stands for Airborne Warning and Control System. The Boeing E-3 Sentry is the most recognizable example. A large aircraft with a rotating radar dome scanning vast areas of airspace from high altitude. But this is not a fighter radar. It is not designed for precision targeting. It is designed for persistence, wide area surveillance, continuous coverage, long-range detection. It looks down at the battle space, and that changes everything. Most stealth shaping is optimized against forward-facing threats, fighter radars, ground-based fire control systems. Those systems illuminate the aircraft from roughly the same altitude and from predictable angles. But AWACS observes from above. Different geometry, different scattering behavior. Surfaces that deflect energy away from a frontal radar may not behave the same way when illuminated from the top or from oblique angles. As a result, the effective radar cross-section of the F-35 can increase from certain aspects. But larger does not mean large. It means less small. Against an X-band fighter radar, the F-35 is often compared to a marble. Against a lower-frequency AWACS radar, it may behave more like a baseball, still extremely small. But no longer at the extreme edge of detectability. Now consider frequency. Fighter radars typically operate in higher frequency bands, such as X-band and Ku-band. Short wavelengths, high resolution, precise tracking. Stealth is heavily optimized against these frequencies. AWACS radars often operate in lower frequency bands, such as L-band or S-band, longer wavelengths. And this is where stealth begins to lose some of its advantage. Long wavelengths are less sensitive to fine geometric shaping. They interact with the aircraft as a larger structure rather than as a collection of carefully aligned edges. Under certain conditions, this allows low-frequency radar to detect the presence of an object that would be extremely difficult to observe at higher frequencies. But detection is not tracking, and tracking is not targeting. This is the distinction that defines everything. An AWACS system may register a weak, unstable return, a signal that appears briefly, then fades. A contact that does not behave like a conventional aircraft. The operator sees an anomaly, but an anomaly is not a solution. To engage a target, you need a continuous, high-confidence track. You need velocity, direction, altitude. You need to predict where the target will be seconds into the future. AWACS does not provide that level of precision. It provides awareness, not engagement. So yes, under certain conditions, AWACS can detect something, but detection alone does not create a firing solution. Now introduce electronic warfare. The F-35 is not just a passive, low observable platform. It actively shapes the electromagnetic environment. It can degrade incoming radar signals. It can inject false information. It can manipulate what the radar system believes it is seeing. This is not speculation. This is electromagnetic interaction governed by physics. Radar transmits energy and interprets reflections. Electronic warfare introduces additional energy to disrupt that interpretation. The result is uncertainty, and uncertainty is the single greatest barrier to engagement. Now make this real. Consider 3 scenarios. Scenario 1. The F-35 is operating at altitude, flying a predictable path with weapons bays open. Its radar cross-section increases. For a brief moment, it becomes more visible. AWACS detects a return at long range, but the F-35 is not blind. Its sensors detect the AWACS emissions. The pilot adjusts heading, closes the bays, activates electronic countermeasures. The detection degrades, then disappears. Scenario 2. The F-35 operates at low altitude. Terrain masking becomes dominant. AWACS is forced to look down through ground clutter. The radar environment becomes saturated with noise. The aircraft's already small signature blends into that environment. No reliable detection. Scenario 3. A networked environment. Multiple radars, multiple frequencies, sensor fusion. One system detects a weak return, another sees nothing. A third detects a different signature. Data is combined. Algorithms attempt to construct a usable track. Sometimes they succeed. Often they do not. And now the system is estimating. The commander is making decisions based on incomplete information. Time passes. The F-35 moves. The opportunity collapses. This is modern air combat. Not binary, not deterministic. A continuous contest between detection and deception. So here is the real answer. Can AWACS detect the F-35? Under specific conditions, yes. At certain angles, at certain ranges, with certain frequencies. But detection is not victory. Detection is information. And information only matters if it can be converted into action fast enough. That is the real contest. Not stealth versus radar, but certainty versus time. The F-35 is engineered to exploit that gap. It delays detection. It degrades tracking. It injects uncertainty. It operates with its own sensor fusion, building a coherent picture while revealing as little as possible. AWACS is designed to counter this. It expands coverage. It integrates data. It increases the probability of detection. But it has limitations. It is large. It is slow. It is highly visible. In a contested environment, it becomes a priority target. So this is not a one-sided interaction. It is a system-level competition. Each side adapting, each side compensating, each side operating under constraints. Now consider real-world analysis. In multiple simulated scenarios, low observable aircraft produced intermittent detections on AWACS-class systems. Detection windows lasted seconds, 5 to 15 seconds, not minutes. Seconds. That is not enough to establish a stable engagement chain. By the time a weapon could be guided, the conditions that enabled detection have already changed. Aspect angle shifts, altitude changes, electronic warfare activates. The track collapses. This is why stealth remains effective, not because it eliminates detection, but because it compresses the timeline. And in air combat, time is decisive. A few seconds can determine whether an aircraft is engaged or survives. So what does this mean? It means abandoning absolute thinking. Stealth is not invisibility. Radar is not omniscience. Both are tools within a dynamic system, and that system is evolving. Radar systems are becoming more adaptive. Signal processing is becoming more intelligent. Stealth materials and shaping continue to improve. Electronic warfare is becoming more sophisticated. This is not a solved problem. It is an ongoing competition. a continuous cycle of measure and countermeasure. Understanding that cycle is the key, not isolated claims, not simplified conclusions, but the interaction between systems operating under uncertainty. So when someone says AWACS can detect the F-35, the real questions are different. For how long, with what confidence, and what happens next? Because those answers determine the outcome. If you want to understand how modern air combat actually works, based on physics and system behavior, not simplified explanations, subscribe. And in the next video, we go one step further. What actually happens when a modern missile tries to hit a stealth aircraft? Thank you for watching. I'll see you in the next breakdown.